So when they tell RL circuit should be resistive and inductive, so we need to draw a basic circuit which will have AC source, a resistance, inductor. This we name it as V of t. This is nothing but R. This is L, and the current flowing I. So over here the voltage across this component would be VR. Over here it would be VL. So we used Kirchhoff's law of voltage. This way in a loop, clockwise loop. So it as V minus I of R minus L. When there is inductive, we need to use the differentiate. Okay, so yeah, we need to use dA by dt is equal to 0. We just place this on the right side, so it's going to be V minus I R is equal to L di by dt. And we again manipulate the same equation. We place this on the numerator, this denominator. So where it does dt by, we place L at the bottom, is equal to di by, this is the bottom again, V minus IR. This is one of the equations, the main equation. We need to integrate this, so we go for integral dt by dl is equal to integral of di by V minus IR. The limits over here would be 0 to t, since there's this variable dt, and over here since the variable is I, we name it as 0 to I, we name the limits like this. So the integration of this, so we know that L is a constant, so we can just write it as L, but in the numerator we consider it as 1 into dt, 0 to t. So we know integral of 1 is nothing but, generally we take it as x dx, so it's x. Over here it's going to be t, so it's going to be integral of this number would be limit 0 to t, inside would be t. So we just write it as is equal to t by L, limits 0 to t is equal to integral of 0 to I di by V minus IR. So when we place limits, in place of t we place t, it's going to be t itself, and when we place 0 it's going to be 0. So the final is anyway t by L. But on the right hand side, since the denominator is a little complicated, we need to make a new variable, like consider a new variable Z, and give the value of this to the variable Z. So it's going to be IR. So we need to differentiate Z, dz by di, dz by di, dz by di, wait, dz by di. So over here it's going to be, since there's no I term, this term is going to be 0, but this term it's going to be minus R when we differentiate this. So dz by di is nothing but minus R. So we place equal to 0 to I di by, in place of this we write Z. We multiply dz by dz because we need to somehow include this term in place of this. So we write t by L is equal to integral of 0 to I. We group these both, dz by di. Over here we know dz by di is equal to minus R. It's di by dz, so we just write di by dz is equal to minus 1 by R. So we place dz by z, the leftover terms, and in place of this we write minus 1 by R. R is a constant, so we take it out of the integral. So we write 1 by is equal to minus 1 by R, integral of 0 to I dz by z. So we know over here that generally when we consider integral of dx by x is equal to ln x, similarly this is going to be ln z, limits 0 to I, t by L. We know the actual value of z, which is V minus IR. So we write minus 1 by R ln V minus IR 0 to I. The LHS is going to be the same. After this step, the same, Z by L is equal to minus 1 by R. We place the limits. In place of I, we place it as V minus IR ln V, wait, minus 1 by R ln V minus IR, and minus, when we place 0 in place of I, it's going to be ln V. Yes, t by L. So we know this property ln A minus ln B is nothing but ln A by B. We use the same property over here, minus 1 by R ln V minus IR by V. Yes, we don't use limits because we have already used it over here itself. T by L. So we just need a plain ln term. So we need to take this on the LHS. So it's going to be minus RT by L is equal to ln V minus IR by V. We need to take antilog. And when we need antilog, we need to add E, and this goes to the power of E. So it's going to be E minus RT by L is equal to E ln V minus IR by V. Since E and ln gets cancelled, cancel it. It's going to be minus RT by L is equal to V minus IR by V. So we need the answer in terms of I is equal to something something. So we need to just eliminate all of them, take them to LHS so that we get I separately. So I'm doing the same. I'm going to take V from the bottom to up. So it's going to be V minus L is equal to V minus IR. This V again to the left. V e power minus RT by L minus V is equal to minus IR. I want to remove this minus, so I multiply minus. It's going to be V minus V e power minus RT by L is equal to IR. I want RI, so we need to take R left. V minus V e power minus RT by L by R is equal to I. V is common, we take V outside. 1 minus e power minus RT by L by R is I. This is the final answer.